First of all, I would like to give a big thanks to the organizers and all my industry colleagues here who are here. I am also joined by my team members from JSW, Mr. Anuj Saini, who is here, Mr. Saket Gaurav, and Mr. Anup Nair. So before we deep dive into the subject, which is technology transforming the usage of steel, I would like to very briefly and very quickly talk about JSW Steel and then go to the subject directly. So, friends, as many of you are aware, JSW Steel today is the largest steel company in India with a capacity of 28 million metric tons to serve our country. It's also the flagship business of a very well diversified JSW group. JSW has other interests in areas such as cement, paints, and infrastructure, which are of national importance. JSW Steel is also one of the fastest growing companies in India, and of course the fastest growing in the steel domain. Its roadmap for the next phase of growth includes a target of achieving 38.5 million metric tons from the current level of 28 in the next 2 to 3 years by FY25. It's also got a very well diversified portfolio of products meeting the most stringent requirements of various end-use segments apart from infrastructure and construction. Over the past 3 decades, JSW Steel has grown from a single manufacturing unit to become India's leading integrated steel company with a capacity of 28 million metric tons today, as I said. And it's got a pan-India presence across the country, as you can see from this map of our country. The largest manufacturing unit, which is also the single largest steel producing facility in our country, is based out of Vijayanagar, which is in Karnataka. It's got a capacity in excess of 12 million metric tons per annum. At JSW Steel, we believe in working very closely with the end-use customers, understanding their end application and tailoring our products to meet the stringent requirements of specific applications in the given end-use sector, including infrastructure construction and buildings. And therefore, some of our colleagues like Anuj, Saket, etc., they are civil and structural engineers who have joined us from the end-use sector, and they understand the requirements of the customer better than the normal steel person. We have also laid the foundation and structures for various infrastructure projects across our country, like this iconic bridge that all of us in Mumbai are aware of. So now that we have been tasked with the responsibility of sharing our thoughts on new technological developments and how they are going to impact the usage of steel in the building and infrastructure space, let me start with the biggest key driver, which many of our eminent speakers in the morning talked about: technology, digitization, sustainability, etc. But I think the biggest driver today, which is driving this sector, is under the able leadership of our Honorable Prime Minister, Mr. Narendra Modi. India has set a vision to become a developed country by, in the next, I think, 25 years, by 2047, right? And a robust infrastructure is an essential prerequisite to achieve this vision. And this, by and large, is the biggest driver which is driving the sector that we are talking about, the investment, the huge investment outlay. So according to the government, has now got the national infrastructure pipeline, which some of our speakers talked about in the morning. And there is a capital outlay of more than US dollars 1.5 trillions in roads and bridges, railways, ports, airports, and housing for all. So this, by and large, is the biggest driver. So in this journey, we genuinely feel that steel can be the material of choice for bridging the infrastructure deficit in developing countries like India, to make them developed country, particularly in infrastructure and buildings. We have a huge opportunity in areas such as short and medium span bridges, so that we are able to bridge this gap in a timely manner. So in addition to the big advantage in terms of much faster project timelines that many of our colleagues talked about in the morning, the steel has unique advantage in terms of the overall life cycle cost also. And some of the photographs here you can see are more than 100-year-old bridges, okay? Like the Pambam Bridge that you see is more than 100 years old. It's under renovation now, but the lifetime or the longevity of the bridge is established in our country, right? So there is a very obvious need for promoting steel for other reasons also, like the society advantage. I mean, many of you, I stay right on the CST road where the flyover has been going on for the last, I think, 7 or 8 years, causing immense pain to all the commuters, the daily commuters who have to wait there for more than 1 hour, inhale a lot of pollution and fumes and carbon monoxide coming out of the vehicles. The same thing had it been done in steel, perhaps it would have been completed in a short span of 2 years. And these kinds of societal costs, the traffic congestion it causes, the environmental damage it causes, is never calculated into the life cycle of a project, right? So there are several ways in which we can do this, and here is a roadmap on how we can perhaps use steel in a more pragmatic, positive and balanced manner. So I am sharing with you a hypothesis, and this is a hypothesis. This is based on approximations, but this is being validated now along with IIT Powai. Professor Siddharth Ghosh of IIT Powai is working along with INSDAC with proper data, and we are trying to validate this. But if you see on the screen, you can see very clearly the first row in the table is the initial cost. And initial cost of steel is around 40% higher than the initial cost of a concrete structure or a concrete bridge. But you know, the time advantage gives us a 1 year advantage straight in the construction, even if you assume that there are no legal and other delays. Considering the interest on the 1 year gain, there is a 12% advantage straight away. Subsequent to that, assuming that both steel and concrete structures last for around 50 years, which is the normal standard life of a structure, we will get a huge recovery in terms of, at the end of the life, of almost, let's say 70% of the total cost of the material can be recovered in case of steel. Then the repair costs are also much lower in case of steel because they are precision fabricated in automated workshops, not on the site. And therefore, you can see the net life cycle value of steel or net life cycle cost of steel is around, I would say 30%, 25 to 30% lower than concrete. So initially, the front loading is more because steel is costlier than cement. But definitely over the life cycle, we have a cost benefit. And I'm not considering the societal costs and the traffic congestions, etc., that we talked about. That's not factored in. But that is a real inconvenience to people in cities like Mumbai, where the traffic is a big issue. Right? So how do we move forward? First of all, I think in addition to the quantitative data, which we are trying to put together along with IIT Powai, and the steel industry as a whole is working on that, not just JSW Steel. In fact, INSDAC is an organization where our colleagues from JSPL and Tata Steel, all of them are supporting this initiative. And through various initiatives, I think, first of all, we need to do some work on perception change management, starting with the basic ecosystem development for, I would say, giving training to the people who are structural engineers on the merits of steel versus concrete, on merit, of course, and not because I come from the steel industry, I'm saying this. But I was surprised to see when I spoke to some of the professors in IIT Powai that in the final year, steel structural design is an optional subject, right? So in the 4 years of their BTech, they don't really necessarily study steel structural design. They study mostly the conventional engineering techniques in civil and so this is one immediate requirement. Of course, there are MTech programs which focus on steel. So if this is the situation in the premier institution of our country, what would be the situation in other Indian colleges? So unless we change the curriculum to suit the requirements of the developing country like India, it's going to be tough. So we have taken initiatives on various fronts. Digitization is something that our colleague, Mr. Shah, I think in the morning spoke very well about. And software-based holistic evaluation tools will also not be difficult given that India is a leader in IT. So any new project can be very easily evaluated at the beginning, at the conceptual stages, what suits better, concrete versus steel, and a lot of policy advocacy. For example, the initial hypothesis that I showed you mentions very, very clearly that steel has an advantage in terms of life cycle cost. But how do we embed that into a government policy that we should look at the life cycle cost necessarily while awarding a project? So these things are ongoing processes. We are all working very closely along with Ministry of Road Transport, the Ministry of Steel, the Ministry of Environment on embedding all these policies into the government policy documents. The second and the most important area is now we are the largest country in the world in terms of population and also perhaps the fastest growing. But I am not sure how many of you will raise your hands when I ask whether we are using the building codes. Now the building codes are there. For steel also the building codes are there. Steel also the structural codes are there. And I was sitting in the Bureau of Indian Standards with my colleagues. And to our surprise, we found that all the codes are there. But I don't know how many of us are really using those codes when we design structures in India. So that's an opportunity, and with the kind of capital outlay that we have, we should be able to proudly say that as Indians, we are using Indian building codes instead of just copying something from Europe or US or some other country. So through some of these initiatives, through standardization, which also is another aspect of knowledge management, it's also another aspect of design rules and guidelines, and the codes actually summarize that knowledge in the form of Indian standards. So this is one initiative that I think all of us need to take to create more awareness. Last but not the least, I think balancing all these three priorities, and many of our eminent speakers have spoken about sustainability, the social priorities, and the economic priorities. Steel structures give a time advantage to reduce the environmental impact and vehicle pollution that we talked about. This also directly helps mitigating the impact on the society, and the overall life cycle cost benefit that we discuss helps us directly in meeting our economic priorities in a longer run. So I think these are all, I think all of you from the end user industry, which is construction, are more familiar with these concepts. But in building using the technology of steel composite columns, we can get more usable carpet area owing to smaller size of the steel columns, right? Similarly, the technology of steel construction using higher strength steels, okay? We talked about 355, there are 450 grades also which we can make. High strength plates are also available in India. Many of the plates which were erstwhile imported for some of the bridge photographs that we showed in the beginning, including Howrah Bridge, today all these high strength steels are readily available in India. So I think the structural engineers have to take that into account, that availability of steel in the country is no longer an issue. And it also results in lesser building or infrastructure weight and lower foundation loads. The prefabricated steel structures made with precision inside modern fabrication and automated fabrication shops substantially reduce the labor intensity on the sites. State-of-the-art modern fabrication shops also give very good accuracy to the components which are constructed, and in fact, one of our colleagues also showed us how 3D printing can be used to achieve accuracy as well as optimal design and engineering of the steel structures. Okay, so these are some of the examples of some modern and special structures like data centers, on which my colleagues like Anuj and Saket are already working with the structural designers. Okay, so these have been actually completed by our own sister company, JSW Severfield, which is a joint venture with Severfield and JSW. So these are actually completed buildings where 100% of the construction has been done using steel. So steel has a very vital role to play in the development of our nation so that we become a developed country by 2047, not only in buildings, infrastructure, but also in areas of national importance like ISRO or atomic energy, or the Mumbai ATC Tower, which is very close to where we are sitting just now. And of course, finally, many of you will be very proud to know that one of the strongest bridges, which is also blast-proof, designed along with DRDO to achieve the security which is required in connecting the northern state of India with the rest of the country. This is also being launched, I think, commissioned very shortly. So suffice to say that steel has a very vital role to play in the faster development of our country. And as representative of the steel industry and the leading steel company of India, I would like to say that we are ready and prepared and I would say geared up to support the infrastructure and construction colleagues in making this happen. Thank you for your kind attention.